All right, good morning, everybody. Hope everyone is doing okay today, and that you hopefully thought about multiplication and all the fraction stuff we have done so far. Now, let's just recap what we have done yesterday. Let's get rid of this. We started our discussion on multiplication, but we kept the first fraction a proper fraction, so less than 1. Then the interpretation intuitively of the multiplication is to take a portion of that second quantity, whether the second quantity is big or small, it doesn't matter. But that's not all of the variations that we can see. We have to be ready. Well, what if the first number is a mixed number instead of a small little fraction only? So let's continue our multiplication. Multiplication continued. First, we try and keep things as intuitive and natural feeling as possible. That's our goal here, right? So imagine we have 4 pieces of candy. Ooh, now can I draw candy? Ooh. 4 pieces of candy. There's the candy wrapper. It's not going to look very good. There's my candy that I put on the table for little Timmy. I'm obviously an immensely talented artist. That shows every time I pick up a pen. I put 4 pieces of candy in front of little Timmy. Okay. If I tell him, take a half of what you see, he's going to know what to do because this is a fraction. This is a proportion, a portion of what, call it whatever you want, that he has heard of before just in speaking and building his language. So let me just update this. Like, this is multiplication, right? So we've associated the of word with multiplication, taking a portion of that. Okay. But if I put 4 pieces of candy on the table in front of him and I tell him, you're going to get 2 times what you see. And then you ask him, how much candy am I going to give you? He's going to say, you're going to give me double this, 2 times what I see. I'm going to duplicate what I see. So when the first number is a small little fraction, I don't get more than what I see. I get to keep some of it. And I just take that, walk away. Compare that with when the first number is bigger than 1, then what I actually end up with is more than what I see in front of me. I am sort of doubling it up. I am duplicating it a certain number of times according to that number. So this first one is, let's go with get. I'm going to get a portion of 4. The second one is I'm going to get to duplicate. Let's not say 4, let's say of what we see. Of what we see in front of us. We get a portion of it. The other one is we duplicate what we see and get to keep all of that. And hopefully there's a bag behind the table that can give me more because you told me I'm going to get 2 times what I see, so I'm waiting. So these two, even though they're both multiplication, intuitively, they are not the same. So as long as I'm aware of that, it's not that bad. So unfortunately, multiplication has this uh, different kind of interpretation when I'm on the far left. Of course, mathematically speaking, there's no difference between these, but that's not where we're at. We're on the far left, where the calculation needs to be viewed in a natural, intuitive, basic way with no shortcuts. Then, unfortunately, the downside is that these two are different, and I should see them and explain them and think of them differently. Now, luckily, by the time I get to fractions, little Timmy would have already done 2 times 4, and he's comfortable with how to see that intuitively. So it's really only one added, and the fact that it's interpreted differently is, in my experience, not that big a deal. So let's see by example how we're going to handle this. We just have to be aware of the difference in intuitive understanding when that first number, or depending on that first number. So we have some exercises. Where are they? 14.8. Exercise 14.8. Might as well do the first one. Actually, I'm going to do the second one. Do the second one first. 2, 5 over 6 times 1/4. Remember now, it doesn't matter what that second number is. It only matters what the first number is in terms of how I approach this. All right, so the second quantity is what I see in front of me, let's say. So now I'm just going to do it on the side here. Let's do it over here, like so. I can see the 2 and 5/6 as 2 plus 5 over 6. Let's say it like this. Applied to what we have. So that means I need to apply the 2, and then I need to apply the little fraction portion, and then put them together again with my intuitive addition. All right, so let's say we're going to split this up like so. I have a little divider line here. First, I'm going to take 2 times 1/4, and then I'm going to take a little fraction portion of that mixed number. And it's going to be done separately, and then I'll merge them at the end. So 2 times 1/4 means I want to see my fraction, and I'm going to double it up. So I'll just draw them twice like this, one below the other. So there's not much to do here. I just want to represent the 1/4 fraction this many times, and that's what I get to keep. So I'm going to split it up vertically in terms of the denominator, of course, just like always. Half, it's a little wobbly, but that's okay. I try and make them equal, but of course it doesn't have to be perfect. And then I'll use some color. And we get to keep one slice and a copy another slice. So that's what we get from the whole portion side. Then the other side is now our previous multiplication approach, where I do have Not pink. Well, I guess pink. Pink's okay. Pink is what I have. This is now separate from the left side. Different argument here. I have a quarter to start with, but let's just make that black. And then my divider lines, making it into 4 pieces. Of course, I have one of them. There we go. Now this is the more complicated side, so this is where I need some words, perhaps. Not perhaps, definitely. So I get, on this side, I get 5/6 of what we have, of the pink. That means 5 of 6 rows, because I've used columns. So I'm going to go horizontally 6 pieces. So split it in half, and then each half into 3 pieces. This tells me I can keep 5 of them. Ooh, that's not bad. So that means I get 1, 2, 3, 4, 5 little pieces, because only from the pink I can take 5 little pieces, like so. But now I see that the left side pink pieces and the right side pink pieces, they're not the same. So putting them all together into a single answer is going to be a little problematic. And for that reason, I have to go to the left side and split them sideways into 6 slices as well. For the left side, I had no need for 6 anywhere. But because I need to make the pieces comparable to see how much I actually have to walk away with, I kind of need them to be the same size. So it's important to not just split these up when you feel like it. There has to be a reason for it. And now there is. A little annoying, but it's only 6. It's not that bad. And then the other one as well. Almost there. All right, so now I see here, from this, I get 1, 2, 3, 4, 5, 6, double that. So I get 12 pieces. Yes, they're pink, sure. Doesn't matter as much now moving forward. So more brackets. All together, we get, of course, 17 pieces. Now again, just like always, I need to put this back in fraction form. So my standard sentence, it takes, I can look at any one of these now, luckily, 24 pieces to make a whole rectangle. We have 17, so we get, I'm trying to use a different word, not have and not take, because those are sort of reserved for other things. 17/24 of a whole. Different, yeah, but also not. Let me zoom out a touch. Also not different. It's just there are 2 sides to the calculation, 2 sides to the argument that I sort of have to do in parallel and then put them together at the end. So different, yes, something I definitely have to keep in mind, but no single part of it is really new. It's just two things at once. Now, I don't think we need to do four of these, but let me know if you really want to. We certainly can, but because they're so similar, I don't know if we need to. Let's see which one should we do next. I'm going to do one more. I don't think there's a need for too many. Let's go with number 3. 1 2/3 times 2 1/4. Oh, a quarter again? Whatever, doesn't matter. Just a fraction. All right. So, remember now, I am applying some adjustment, some instruction on the 2 1/4. So this is going to split into two instructions, really. One is I have 1 times 2 1/4, and then I get to also take 2/3 of 2 1/4. See how much I end up with. So I only get to keep the 2 1/4 once, but it's better than nothing. So, of course, the annoying part when we're working with a lot of mixed fractions here is that I have to draw a whole bunch of rectangles. And I might not be able to squeeze them in very well, but let's try. Yeah, I don't think I'm going to squeeze them in. Yeah, I'm going to have to stack them a little bit, and that's okay. Now, at this stage, remember, I don't need to necessarily split up all of these into 4 slices because I have 2 holes already. So as far as I'm concerned at this stage, this whole rectangle, I'm getting it. Ew, nice. I'm gonna get a lot, but not that last one. I only get a portion of it, so I do need to split that one up. So yes, after you've done this a while, it gets a little tedious. Meh, not like that. And certainly when you get the hang of it, it is just a hassle to draw larger mixed numbers when what we're doing doesn't really change. So I get a whole bunch. Okay, we'll see what we get in a second. On the right, I have a lot to work with now. It's a little unfortunate. It's not going to be in a nice line, so I just have to be careful here, but that's okay. Do it like that. Try to make them as equal as possible. First one doesn't look quite the same, but it is. Oh, whoa, whoa, whoops. I don't need to color it at this stage, right? I mean, I don't need to split it up. I have all of this, all of this, and some of the last one, sure. So let's definitely split that one up. So you might think like, oh, well, isn't it a little silly? I already drew the same thing. Yeah, but I'm going to do stuff to this one, and I don't want to mess up what is contributed from the left side. So it's better, in my opinion, to do a duplicate. So this is what I have. So now let's write down some sentences. We get to keep, or whatever words, keywords you want to associate here. We get 2/3 of pink stuff. 2/3 means 2 of 3 pieces. And I'm going to choose rows as those pieces because I have columns already reserved for something else. So I'm going to have to make rows of 3 here. Almost there. 3 is not that bad, luckily. Like so. Now, these are technically all in line, right? So I get to keep 2 of the rows and not the last one. But in order for me to see what I keep, it's not quite as clear entirely. You can now take a shortcut, and it really depends on your audience. You can say here that not all of my whole rectangles are going to get broken up or are broken up. I'm eventually going to merge all these together. This this first whole one is going to stay whole, and this one. Sure, I have to do something with that. So I don't ever have to split these guys up. On the left, on the right here, I have a shortcut that I can take if I'm comfortable to do so. Now I can say, if I look at this first rectangle here, I keep 2 of these rows and I lose one of them. And then I keep these top 2 again for the next rectangle. I can make a hole by sort of moving this one that way and fill another rectangle. And then I get to keep 1 of this middle row I get to keep as well. That might be a little confusing. Let's do sort of a halfway in between these two. Can I go back? No, I can't click the undo button. I don't want that arrow there. Get away from me, arrow. Let's meet in the middle and say we keep the whole rectangles on the left, but on the right we just do our thing. Okay, so in order for me to see what I actually have, I need to split them up vertically as well. And I'm just going to do it throughout. That's of course going to be in 4 pieces. 4 columns, 4 columns, 4 columns. Now I know eventually, let's leave it for now. I wanted to say eventually I need to split this up as well. But at this stage, I'm going to finish my right hand side first. So we get 1, 2, 3, 4. Another 4 is 8, 12, 16, and another 2 is 18. I'll remind you they are pink. Okay. We also get some stuff here on the left, and I can't quite make a sense of this little slice here and compare it to the little square pieces. So I'm going to have to split that up. But I'm not splitting up the holes. They're not going to get broken in any way. Oops, no, it was thirds, right? Alrighty. So now here, let's separate this nicely. Here we get 2 holes. Oh, come on. 2 whole rectangles and another 3 pink pieces. Okay, now we're close to the end. That we can say now all together, we get, so far, two whole rectangles and another 21 pieces. So now I want to see how much does it take to make a whole rectangle. Standard sentence, it takes, how much? 3 rows of 4, so 12 pieces to make a whole rectangle. And we have 21 pieces floating around. So I can definitely split this up into 12 and 9. This 12 will be another whole rectangle, and the 9, unfortunately, is not enough. With my two holes, I actually got, so we get 3 whole rectangles and 9/12 of another. Again, I don't want to sound like a broken record, but I am not simplifying that. Go and watch the other mini rants if you want to know more. And there we go. We got a lot because we took a lot. No, that's not the reason. Aw, silly line. We applied our instructions to quite a bit. We get to keep a copy and then a significant portion of that same amount. So it makes sense that we end up with a nice amount. Now, feel free to correct me, but with this being so similar to what we've done before, I don't necessarily think we need more practice. It just takes time to split it up and draw carefully and so on, especially with the mixed numbers, especially with the bigger denominator. It just takes time. But the concept of what we're doing here is not really new. I just have to realize that with a mixed number as the first one in my multiplication, the intuitive understanding of the instructions, that comes in two parts, and I have to split it up accordingly. And if I haven't thought about this before, I sit in front of little Timmy, and I need to explain mixed number multiplication on a basic level, I'm not going to know what to do. I'm not going to know how to explain this effectively. It's going to sound very confusing if I haven't prepared and thought about it for myself. What does this multiplication mean? What is it telling me to do? I need to think about these things beforehand. So what happens? People do have to do this. They're not prepared. They're anxious. They don't really understand. So they just use the shortcuts. And Timmy never gets to build up his number sense and understanding of fractions. And he gets anxious too because he doesn't really understand fractions either. And so the cycle continues. But we can stop it. But it requires of us to think about these things. And the more basic it becomes in my explanation, sometimes the more difficult it becomes. Because I don't have those shortcuts and those mathematical properties to rely on to make it look easier than it actually is. All right, we are making progress. We have only one left, and it is, I don't want to say it's the big one. I mean, multiplication had something to it, but division is certainly last for a reason. So now we want to follow a similar approach, keeping things as basic and intuitive in our understanding and our explanation. And if I want to understand what the simple, basic, introductory level meaning of division is, let's just take integers. Let's just take familiar things like 100 divided by 5. Nice numbers, easy to work with. At this stage, I wouldn't come to fractions if I can't do this already. But now I have to put this in words. So my question is, what sort of word problem, what setup could result in this calculation? So that instead of the calculation, I can say instructions in words that is equivalent to this. One is, let's say we have 100 people. There's more than one way to interpret this. I'm going to go with the one that I find works the best moving into fractions. I have 100 people. Let's suppose they were instructed to where they come in groups of 5. Let's say groups of 5. Let's say every 5 people, they come in a group, whether it's a family or someone else. They register in groups of 5. They all have the same color shirt on, and every group has a different color so that they can be recognized. Regardless, they come in groups of 5. So as I look at the 100 people, they might be walking around and be mixed up, but I know that if I see red shirts, there are 5 red shirts. There are 5 blue shirts. There are 5 green shirts. There are groups of 5 everywhere. Then I could ask a couple of questions. One question is, how many groups are there? And the calculation to determine that is exactly 100 divided by 5. I can also ask a different question that results in the same calculation. If I have to sort of hand out the shirts, I'm going to have to know how many colors I need to make. I need to be prepared before the people show up. I'm going to have 100 people. I want them to be groups of 5. So I'm going to have to get ready with my shirts so that every group gets a different color shirt. I need to know how many colors, how many groups. But I can phrase it in a different way. I can say, how many times can 5 fit into 100? I have these groups of 5. How many times will I be able to fit a group into the 100? That's exactly the same. These are exactly the same. Or not, I guess in words they're not the same, but they are equivalent in concept and in the resulting calculation. Okay. Now for fractions, I find that the second one is just a touch better on the intuitive level for me, but I have to be okay here first with the fact that these two are the same question. They'll always have the same answer, and it'll always be the division answer. So with division, there can be variations in the wording for the exact same calculation, making it a little bit more confusing potentially, especially if I don't vary my words enough to get students, when it comes to integer division, to get them to be comfortable with variations in the words, all corresponding to division. By the time they get to fractions, I want to be able to switch and rephrase this to something that works for me. Now, the second one, for me personally, feels still a little bit more natural when I get to fractions, but when it comes to integers, I really don't care. I need to be happy with all of them, of course. So now, what does this mean? This means the first number in my division is what I start with. That's what I have. Remember in multiplication, the second number was the quantity that I have to start with and that I applied some instructions on. Now the first one is what I have. And then the second number is my group size, if you will. It's the size of a group. And then the division tells me to fit in that group size into what I have and count how many times I can do that. Okay. So now when we move on to fractions, nothing's going to change. The meaning of the instructions on an intuitive level will be the same. So let's go and find an example to do that. Division, division. There we go. 14/9. Of course, we'll do one example today and finish it up tomorrow, but we can at least start. 14.9, and then you can sort of just let it sit in the back of your mind, and then we'll confirm that understanding tomorrow. What I have is, doesn't really matter what that first one is, we'll see. Actually, it doesn't matter what any one of them is, but for a first example, let's take a couple of proper fractions. They're easy to draw, easy to work with, just easy all around. Okay, now remember, I have the first quantity, regardless of what it is. So let's draw that. I want to make it nice and big. Let's make it nice and big. I have to split it up into 6 slices. Here I definitely want to give myself some space because it's my first example and I'm not used to it yet. And I know that I have 5 of these slices. 5 of them. Almost dipped into the 6th one. Nope, I don't have it. Okay, so that's what I have to start with. So now my group size is 1/4 of a whole rectangle. There's nothing following this 1/4. It's in reference to a whole. So I need to figure out what on earth is this. That is why I'm going to go horizontally in 4 pieces so that I can make sense of this because, let's clarify that, that's 1 of 4 rows. Because I've used columns, I can use rows for the interpretation of this fraction. So I'm going to go half of half. And this is where people struggle a little bit to separate the different methods from each other, because this that I'm doing now is in reference to a whole rectangle. So for the immediate future, there is no pink. Pink is something I look at when I do the division instruction. And right now, I'm only trying to understand what that second number is. I haven't gotten to the division yet, so I haven't gotten to the pink yet. And people struggle to look at this rectangle without seeing pink. If that is the case, then go and draw it somewhere else. copy it somewhere else so that I can see 1 in 4 rows that corresponds to 1, 2, 3, 4, 5, 6 pieces. Those pieces are not pink. They're pieces in a standard rectangle split up in 6 and 4 slices. So this is my group size. 6 pieces. Instead of our, no, not that one. Instead of our basic example with the shirts and the people, that came in a group of 5. Now we have a group of 6. Now we're not going to do it exactly the same as the people, in the sense that I'm not going to do an integer division in its in the same way as I'm doing 100 divided by 5. You could, but in an attempt to try and stay as far left as possible, I think there's an even simpler, more basic approach here. By simply going and looking at what I have and making groups of 6. I'll use blue so it's easy to spot. So let's make a group of 6. There is one group of 6 I can make. Or I can say 6 can fit in 1 time so far. 6 can fit in, that's 2, 3, maybe like this. It really doesn't matter, right? As long as I cover, or as long as I fit in as much as I can. Or fit in the group size as many times as I can, rather. And then here I can fit it in. And your blue part might look a little different. Doesn't matter. And I have 2 left. I don't have enough for another group to fit in completely. Okay, that's a little visually much nicer as well. And if I can do something visually instead of uh, sort of with a cold 100 divided by 5 calculation, it's going to be better. It's going to come across much more intuitive and natural feeling. So now let's write some sentences here. We can fit the group into, I'll write that in pink to emphasize it, into what we have. We can do that 3 whole times with 2 pieces left over. Yeah, those pieces are pink, sure. Sure, we can make them pink. Okay. Now the fraction calculation here doesn't actually matter right now, right? We've converted things to an integer calculation. We've gone even further to the basic side by not saying, what is this, 1, 2, 3, 4 times 5? Not saying 20 divided by 6 is 3 remainder 2. I'm going even more natural, more intuitive than that. Though it does depend on your audience, you can take that route as well. But with the goal of what we're trying to do here in mind, I think if I can do things visually and as basic as possible, that's going to be even better and easier to understand. So I don't even rely on integer division. It's even more basic than that. Okay, so I'm fitting in my groups because that's what division tells me to do. I can do it 3 whole times and 2 little pieces are going to be left over. Now I have to write my answer back in fraction form. And this is where things are a little different than the other ones. Previously, when I think about addition, I had portions of a whole, assuming now they're just the proper fractions. Portions of a whole, put them together, I get some portion of a whole. Maybe a lot more, but something like that. So my answer for the addition question is in reference to a standard whole rectangle, just like the originals were. Same for subtraction. I start with portions of a rectangle. I have a removal instruction, but I end up with portions of a rectangle. So my answer and my original fractions are in reference to the same kind of thing. Multiplication. Do we have a multiplication? Sure. Let's just look at this simpler version on the right, because multiplication is a little different. I have some portions of a rectangle, regardless of how much. I have to take some portion of that portion. So I'm ending up with portions of a rectangle. So again, my answer is the same kind of answer, same kind of meaning as what I started out with. But for division, it's not. For division, it's not. For division, I start with, man, what's this line doing there? My hand clearly shows, drag it down, thank you. For division, I start with a portion of a rectangle, right? But because of the instructions of having to count how many times I can fit something else in, the answer isn't a portion of a rectangle. The answer is a number of times I was able to do what the instructions tells me to do. So how should I write this here? Let's say here, the answer is, let's say it here, a number of times I'm able to do what they tell me to do, not a portion of a rectangle. So because the instruction is different when it comes to division intuitively, the answer sort of, I don't want to say the units of the answer, but in a way, the unit of the answer and the unit of what I started with, they're not the same. I was doing something completely different. So here, it's a number of times that I'm trying to represent in fraction form. Yeah, not confusing at all, right? So my answer, let's just say it like this. My answer is, of course, going to be 3 whole times. And then I can do this fitting in instruction, not another whole time, but I can fit in another 2 of the 6 that I need. So 2/6 of a time, or 2/6 of a group, I can fit in after my 3. So that is my answer. I can do what they say. Let's try and zoom out and see the whole thing. Sort of. I can do what they say I should do, this fitting in procedure, 3 whole times, and then another portion of a time, so to speak. Or you can rephrase it. How many groups of size 6 can fit into what I have? 3 groups completely can fit, and then another 2/6 of a group. So I do have some flexibility in terms of how I want to phrase it that makes the most sense for me. But it's all connected to my understanding that's already established when it comes to integer division. Group size, how many groups can fit, or how many times can I fit a group of a specific size? Those things are equivalent when it comes to the intuitive understanding of division. I'm doing the same thing. I just have to sort of convert these fractions to integers in a way, definitely the group size. And for what I have, I didn't even bother writing that as 20 and doing division. I'm just doing a manual, basic, fitting in the groups visually, seeing it one by one. It's even better, even easier to understand. And then I just have to get to grips with what my answer is saying. And what kind of answer is this in reference to? It's a number of times it can fit, or the number of groups that can fit according to the instructions. So obviously, we need more practice. We will have more practice tomorrow. But let me just check. Are there any questions for right now before we pause this to pick it up again tomorrow? Okay, it has gotten very quiet over the last week. Now I know I sound a little under the weather perhaps, but that's not an excuse for you to not interrupt me when you have questions. And I know for a fact that when it comes to division and these fraction calculations, there should be a lot of questions. And to be honest, the fact that no one is saying anything is quite concerning to me because the test is coming, the exam is coming, and I know these things are not easy. It is up to you. I'm giving you the opportunities to ask questions, whether you take it or not. But in the end, if you look back and think, oh, I should have done more, why didn't it go well? It's because no one is saying anything. So just know that you're not getting the most out of it because no one is giving me any feedback. It's totally up to you, but I just want to go on record to say that we should have more of a discussion to get on top of this and master these concepts because they're not easy. But it is up to you. I will see you guys tomorrow.